All right, here we are. We're going to sketch the graph of p of x equals a negative x plus 3 quantity squared times x plus 1 quantity squared times x minus 1. And we're going to describe the end behavior with the arrow notation. All right, so the first thing we want to do are find intercepts. That's easy things to do. The first intercept we're going to do is the y-intercept. There's only one of them whenever we're dealing with a function. At most, I should say. So we have p at 0 is equal to negative 0 plus 3 squared times 0 plus 1 squared times 0 minus 1. So just plugging in zeros everywhere I see x. Okay, so don't forget, keep that negative. That's 3 squared times 1 squared times negative 1. So the negative stays out there. Square each of the numbers first. So that's 9 times 1 times negative 1. And so negative 1, so I have a negative and then a negative, which will cancel to become positive. So then 9 times 1 is just 9. That means that my ordered pair is 0, 9. That is the y-intercept. X-intercept is when y is equal to 0 or p of x is equal to 0. Okay, so we're going to let negative x plus 3 squared times x plus 1 squared times x minus 1 equals 0. So for each one of the factors that have an x as part of it, we're going to set it equal to that 0. So this is nicely factored out for us. We have x plus 3 squared is equal to 0. So x plus 3 must be equal to 0, which means x must be equal to negative 3 for it to be true. Okay, now looking at its multiplicity, remember the multiplicity is the power of the factor. So in this case, we have a power of 2. So we have an even multiplicity, which means that at negative 3, 0, that intercept, it's going to touch. Okay, now the next factor. X plus 1 quantity squared is equal to 0. So that means x plus 1 must be equal to 0, so x is equal to negative 1. So at its intercept, negative 1, 0, looking at its multiplicity, which is 2, so it's an even multiplicity, that means, again, it's going to touch at that intercept. And lastly, we have x minus 1 is equal to 0, so x is equal to a positive 1, so we get 1, 0. Its multiplicity is that unseen 1 here. So this is really to a power of 1, which is 1 is odd. So it crosses here. So we're going to have the behavior at that intercept is that it will cross. Okay, so now we have our intercepts, our x-intercepts, and their behaviors. Okay, now to determine the end behavior. So we need the degree of the polynomial, and we need to know its leading coefficient sign. So first thing is to look at the degree of the polynomial. So to find the degree of the polynomial, I would look at if, so this has a power of 1 on it, this has a power of 1 on it, this has a power of 1, and this has a power. So all those unseen powers of 1 are there. So this will add to this, will add to this, because all of these had a power of 1 on them. So 1 multiplied to 2 is 2. 1 multiplies to 2 is 2. 1 multiplies to 1 is 1. So 2 plus 2 plus 1 gives me a power, or a power of 5, so a degree 5 polynomial. So n is equal to 5. Then I look at the leading coefficient. The sign of the leading coefficient, since this here is negative, notice that all the x terms, once this hits that first term, it's going to be, so all of these are positive 1s in front, and this has a positive a negative 1. So negative 1 times positive 1 times positive 1 times positive 1 ends up just being negative 1. So a sub n, the leading coefficient, is negative 1, which means it's less than 0. So this means implies that it tells me that how the graph will now the end behavior based on these two things. Okay, so since we have an odd degree and we have a negative leading coefficient, this all brings me to that we have a disagreement between infinities. Okay, so what happens is as x goes to positive infinity, y will disagree and go to negative infinity. And as x goes to negative infinity, y will disagree and go to positive infinity. And that's what I mean by the infinities will disagree. This only is true when you have an odd power, or sorry, odd degree, and then a negative leading coefficient. Okay, so with everything there, we can now sketch the graph. Remember, it doesn't need to be perfect, just needs to be good enough. All right. So -3, 0, about right there. Negative 1, 0 is there. 1, 0 we have there. And then 0, 9. Again, once it's labeled, it's true. So make sure to label everything at the end. So the end behavior. So how does this end behavior work? So our end behavior, this is what I want. So this is my end behavior. So as x goes to positive infinity, so what I'm saying is going this way, y will go to negative infinity. So y is going to go down. So on this side, we're going to go down. That's not what I wanted. This one. So on this side, we're going down. And then as x goes to negative infinity, so as we're going that way, y is going to go to positive infinity. That means we're going to be going upward. So for this, we're going to be up. So that's how we're using that end behavior. Now the behavior near the intercepts is the next thing, starting off with the most left. So that's -3, 0. We're going to touch. Since we're already above the x-axis, that means that we're going to be coming down here. Now we're touching. So my little arrow that I put there to indicate that I touch, to help me remember that. Then at -1, 0, we're touching again. So again, I'm up here somewhere. So I'm going to come and touch and then basically bounce off of it. So we're going to come, bounce off the intercept. Okay, we have to go through. So we're going through the y-intercept, and then for the last x-intercept at 1, 0, it says we cross, so we're going to go through it just like we should be going. So we can go down on that side. So start up here, bounce up. Oh, I forgot to draw the arrow to say go through. There we go. We're going to bounce off. We're going to come back up, bounce off again, come up, go through, and then go down through the other last intercept. Now label everything, so now it's true. And you're done.